A crate with a mass of 20 kilograms is on the floor. You push it with a force of 100 newtons. What is the acceleration? How far does it travel in 10 seconds? What is its final velocity? The first thing we need to do for this problem is to identify a few key concepts. So in this problem, we are going to be using Newton's second law. And that simply states that the force is going to equal the mass times acceleration. And that's going to find us this acceleration target variable that we're going to be looking for. We're also going to use a few kinematic equations because the kinematic equations relate distance, acceleration, and velocity. Now that we know which concepts we're going to be using, which is the kinematics and Newton's second law, let's go ahead and make sure we know what was given to us. So on the side, we can go ahead and note that we were given the mass, and we were also given a force, which we'll label as f of x. The mass was 20 kilograms of the block, and we were pushing the block with a 100 Newton force. Once you go ahead and label the concepts that we're going to be using to solve the problem, and we make sure to note down the variables that were given for the equation, we can go ahead and start to set it up. The first thing we're going to try to solve for is the acceleration. Now, you may not want to probably solve for the acceleration first. You maybe want to try and solve for the distance or even the final velocity. But it's important to write down all the equations that we can start with so that we know what it is we should tackle first. So let's just start with Newton's second law. And that states that the force in the x direction has to equal mass times the acceleration, which would also be in the x direction. So I'm going to go ahead and box our target variables so that way we are clear what it is we are going to be solving for. The next thing we need to solve for is the distance traveled in 10 seconds. So the kinematic equation we are going to be using is going to be the distance equals the initial velocity times time plus 1/2 the acceleration times the time squared. Again, in this problem, we are looking for the change in x. Also note that the acceleration we're going to be using for this problem isn't simply a, it's going to be the a of x. Next, we're going to need to find the velocity, and we can use the final velocity is equal to the initial velocity, each of those squared, plus 2 times the acceleration as well as the change in x. And if you note, this is what we're looking for right here, that each of these problems are going to have the variables plugged into the one below it. So if we want to solve this problem, the first one we have to tackle is the acceleration, then we have to find the distance, and then we can go ahead and we can find the velocity. So let's go ahead and start to evaluate these problems now. So starting out with the force, we'll go ahead and write that down again. This is the summation of the forces in x direction equals your mass times the acceleration in the x direction. Since we're solving for a, we can go ahead and just divide that over. And then once we plug in the values, we have 100 divided by 20, which is going to equal 5 meters per second squared. And that will be our first target variable that we have found. And now after that, we need to find the change in x. So we'll go ahead and divide this. We have delta x is going to equal, I'll go ahead and write just below that, velocity initial times time plus 1/2 a, this is going to be the acceleration we just found, times time squared. Now we know that v initial is equal to 0 because initially we are not moving. So this will go ahead and cross out. And then we just need to plug in the acceleration and the time that we were given. So all this will equal 1/2 times 5 times 10 squared. And this will equal 250 meters. There is our second target variable. And now all we need to do is to solve for the velocity. We'll go ahead and use this bottom portion here. Remember, the equation we were using was v final squared equals v initial squared plus 2ax times delta x. Now again, this initial velocity is 0, so we can go ahead and get rid of that to start with. And we have v final is equal to the square root of 2ax times delta x. And if we go ahead and we plug in all those quantities, which we have from the beginning with the 5 meters per second squared for the acceleration, 250 meters for the distance, we are going to come up with 50 meters per second. And these are our three values. Our next step is then to go ahead and review our results and to evaluate it. And each of these came out in the correct units. We have meters per second squared, we got meters, and we got meters per second. The other thing to note is none of these answers are exaggerated to any drastic amounts. We didn't end up with an acceleration of maybe 500 meters per second squared. So considering gravity is going to be, if we rounded it off to 10 meters per second squared, we had some reasonable acceleration.